Okay, today's lesson, we're still dealing with normal probability calculations. We'll be using z-scores and this z-score chart to find different types of information. However, what makes this different from the last video is that this time we're given the percent. So all of our calculations will be a little bit backwards. Our first step is to draw a normal curve. Okay, go ahead and mark your mean and see what it says. So we're talking about the length of human pregnancies from conception to birth varies according to a distribution that is approximately normal with a mean of 266 days and a standard deviation of 16 days. All right, so the mean is 266. Okay, so let's mark that on the distribution, 266. Now, how long do the shortest 20% of pregnancies last? Well, 20% will definitely be less than 50, so we'll put it somewhere over here. Okay, so we'll call this the shortest 20% of pregnancies. So this is 20%. We also need to draw the units. Okay, these are pregnancies. No, it's not how many pregnancies. This is days, I'm sorry. We're talking about 266 days, so those are the units. Okay, the units are mandatory, they are worth points. Now we will make the z-score version of this graph, okay, which should be identical to the graph we just did, but instead of a mean, we will put 0, all right, for the z-score in the middle there, and we still will have our bottom 20% labeled like before. Alright, so bottom 20%. Okay, oh, and this must be labeled z-scores. Okay, so we are looking for this number. Like, how far over is this? How many days is the bottom 20%? So here's what you do. We're going to start with the percentage that we are given, 20%, and we're going to work backwards. So we're given 20%. 20% as a decimal is 0.2. Okay, now I'm going to go ahead and write that as 0.2000 to make it the same length as all these nice values on my z-score table. All right, the zeros don't change anything. Okay, so now let's look at the table. 20% is less than the mean, so we're definitely going to be on the negative side of the chart. So make sure you're on the side with the negative z-scores. Okay, now remember, we're looking for 0.2000, or as close to it as we can get. So these are all 0.1s. Okay, and here we go. So right in here, these are the two values. Okay, somewhere between this one and this one. All right, will be the 2000. Now, if I forget about the decimal point for a second, I have 2005 and 1977. Which one of these is closer to 2000? Okay, obviously 2005 is only 5 away, so that's going to be closer. So that's the decimal we're going to use, 0.2005.
Hey, right here, I got to talk to you, sir.
Okay, so 0.2005 is closest. Write that down. Okay, so that was the closest. So let's go ahead and translate that into a z-score. So looking over here, I've got my negative 0.8, that's part of it. And looking up here, I've got my 0.04, that's the other part of it. If I put those together, all right, that's negative 0.84. So that is the z-score. So z is equal to negative 0.84. Okay, so we're halfway there. Since we have a z-score, let's go ahead and include that on our z-score distribution. Okay, so this is negative 0.84, which is not quite one standard deviation away, so probably shouldn't have put it that far over, but I'm not going to change it now. So now we need to find the actual value. So here's what we do. Let's use the formula, our z-score formula. We know that we find the z-score by doing the value minus the mean divided by the standard deviation. So now we have a z-score, and so I'm going to substitute that in. So this will become negative 0.84 is equal to the x value, which will be right here, minus the mean. What did they say the mean was? Wait, yeah, the mean is 266. So minus 266 divided by the standard deviation. And the standard deviation was 16 days. All right, that's my standard deviation. Okay, so that means divided by 16. So all we have to do is solve this for x. Easy enough. We will just multiply by 16 on both sides. Okay. So let's see, 16 times negative 0.84, right? Okay, that's negative 13.44. So I get negative 13.44 is equal to x minus 266. All right, so last step to get this x by itself, I need to add 266 to both sides. Okay, so that will give me x by itself. Okay, so back here I can just do plus 266, and I'm getting 252.56. Okay, now that is the answer that we're looking for, 252.56 days. So let's include that on our picture right now. So that's this mark right here is 252.56 days. Okay, there's my units. So now in the fourth box we will put our sentence. All right, so the question is, how long do the shortest 20% of pregnancies last? And now we have found that answer. So just reword the question as your answer. So you can say the shortest 20% of pregnancies last less than, and let's see, what did we decide? 252.56 days. And that's the end of that problem. Okay, let us move on to problem number 2. All right, in what interval do the middle 90% of pregnancies last? All right, once again, we will start off by making our normal distribution. Okay, like this. All right, same mean, still 266. Now we're talking about the middle 90%. Okay, so that means we're going to go the same amount to the left and the right. We want 90% of the data, so I'm going to make this pretty wide. You know, something like this. Okay, and we want the middle 90%, so I'm going to shade in between these two lines. Okay, and this red I just shaded is supposed to be 90%. And we are looking for these two values. While we're at it, let's go ahead and get our z-score distribution set up. Z-score always has the 0 in the middle. And okay, once again, this is our 90%. Now labeling, this is still days, all right, so those units are mandatory, and this is z-score, so z-scores. All right, so it's time for the calculations. All right, this is the part that's going to blow your mind a little bit. The 90%, we cannot use the 90%. All right, this chart, the table of values that we have, it is not a chart of values that go between anything. It's always got to be to the left. So this chart doesn't know anything about between two numbers, only to the left of numbers. So what we can do, we can use this part over here on the left to get this question mark right here. If I knew this value, that would be helpful. But let's see, is this going to be 10% over here? All right, because that's 90. Does that mean this is 10? No, because we also have this part over here as well. But we do know that these two will be the same. So if we've got 90% here, that leaves 10%, but the 10% has to be shared equally between these two empty parts. So that means this over here is 10%, and then this over here is also 10%. Wait, I lied. I meant 5% and 5%. Okay, that's good to know. So, this 5%, you know, that is a value that's to the left of this number. So I can use this 5% to find my z-score and find this value. So let's go ahead and do that. Okay, so using the 5%, all right, so I've got 5% as a decimal. Remember, I have to move it twice, so this would be 0.05. Okay, and I'm going to go ahead and put 0.0500 just to make it the same length as all these decimals on the chart. Now, let's find the closest thing we can to this. Okay, let's see, 0.0. So I got 0.00, here's 0.2, okay, 0.3, here's 0.5, Okay, so it's between these two numbers. Okay, 0.0500 is going to be between these. And you know what? I think it's actually right in the middle between these two. Because this one is 5 away, and this one is also 5 away. All right, so when it's exactly the same distance away like this, if that happens, I will accept either one, okay? Just bottom line, I'll accept either one. So I'm going to go ahead and use the 0.0505 as the closest. Okay, so just write that down. 0.0505 is closest. Okay, now let's see what z-score that gives us. Okay, 0.0505, that means negative 1.6. Negative 1.64 using that decimal. So negative 1.64. Okay, so we can go ahead and use that z-score to find this value right here. Okay, now before I do that, all right, so we found the first z-score, but I really want to find the other z-score as well. Let's go ahead and mark this on the picture. Negative 1.64 is right here. Okay, before we do the rest of the calculations, let's find this z-score. Now, see if you can understand this. Remember, we always need the part to the left. So the part to the left of this question mark was 5%. That's why we use the 5%. Now I need the part to the left of this question mark. Okay, what is the part to the left of this? See if you can see this, guys. This coming from the left, this is going from here all the way to here. Okay, now what percent is that I just did? See if you can tell why this is 95%. Okay, see the red zone is 90%, and then this green part here is an extra 5. So if you put that all together, the 90% middle plus the 5% tail, that's 95%. So everything to the left of this question mark is 95%. Or you could think of it as 100, you know, up to this line is the whole picture minus this little bit on the end. So this mark is a 95% mark. All right, so 95% is what I will use to find this question mark. Okay, so I'm going to do that in purple. So 95% as a decimal would be 0.95. And I'm just going to add on 00. All right, let's find the closest thing we can find to 0.9500. Okay, this is definitely going to be on the positive side of the paper, so flip over to that. Okay, let's see, 0.97. All right, here I've got 0.95. Okay, 0.9505. Okay, so we're in that same situation again where this is exactly in the middle between these two. 0.9500. This one's 5 away, and this one is also 5 away. So I'm going to use the 0.9505. Thank you. Okay, I'm going to use the 0.9505. So 0.9505 is closest. All right, and that is going to give us a z-score okay, of 1.65. You know what? I changed my mind. See how last time we did a negative 1.64? These z-scores really should match. So I said we could pick either one, but I'm gonna change my mind and pick this one. Because the z-scores really should match. Okay, so this way I'll have positive 1.64 to go with my negative 1.64 from before. Okay, so I'm using the 0.9495. Okay, so that's going to give us a z-score of positive 1.64. Okay, now we can go ahead and do the rest of our calculations. And yeah, let's put the z-score on this chart. In fact, you know, it's the middle 90%. I didn't really even need to go through this second calculation. If it's the middle 90%, you know it's going to be symmetrical. So if this is negative 1.64, you know this has to be positive 1.64. So we really could have skipped this purple part. Okay, so let's do the rest of our calculations. Okay, and I think we will use that shortcut this time. So I'm using the z value of negative 1.64. Remember the z-score equation, right? Z is equal to the x value minus the mean divided by the standard deviation. So using negative 1.64, that gives us negative 1.64 is equal to the x value minus the mean, 266, over the standard deviation, which was 16. So we have to multiply by 16 on both sides. All right, 16 times negative 1.64 gives us negative 26.24. And that equals x minus 266. All right, because these just cancel out. Of course, I'm going to add 266 to both sides now. Okay, and it's going to go a little bit out of the box, but I'm going to deal with it. So that's going to give me x equals, okay, plus 266. That's 239.76. Okay, so that is my first x value. That's this one over here to the left. So let's go ahead and add that to our picture. All right, 239.76. Okay, now we need to find the other one. Okay, or we don't really, because we know it is the middle 90%. Again, these should be symmetric. So if this is, well, you know, I guess this is not 0. Let's just calculate it again. It'll be easier. So we'll just calculate it again. So using a positive 1.64 now, then I've got 1.64 is equal to x minus 266 over 16. Once again, we will multiply both sides by 16. Okay, looking at what happened before, it was negative 26.24, so you can bet that this will be positive 26.24. Okay, is equal to x minus 266, because these cancel out. And then I add 266 to both sides. Okay, so that's 266 plus 26.24. All right, that's 292.24. Okay, let's go ahead and put that in our picture. All right, 292.24. So these will give us the answer to the question. Okay, so the question was, what interval represents the middle 90% of pregnancy length? Okay, so just rewording the question as my answer, it will sound something like this. The middle 90% of pregnancies last between let's see, what did we decide? 239.76 days and 292.24 days. And there you go. Okay, I'm gonna have to go to lunch right now, so I'm going to stop this video here. And all right, so we did problem number 1 and 2. So that's a good example. So hopefully I'll get to make the rest of these videos, but no promises. But at least I'll go ahead and post this video.